In this section, we will discuss about Laplace transform of integral. L of integral 0 to t f of tau d tau is equal to, that is a Laplace transform of an integral is equal to 1 by s into f of s. Normally we use notation f of t, but here we use f of tau. That's only a function of a variable tau, and after integration and substituting the limits we get the function as a function of a variable t. Okay, so the result is L of integral 0 to t f of tau d tau is equal to 1 by s f of s. So what is its inverse? Therefore L inverse of 1 by s f of s is equal to integral 0 to t f of tau d tau. So to find the L inverse of a inverse transform of a function of this form 1 by s f of s, just we have to find out the integral 0 to t f of t dt. Similarly, the L inverse of f of s divided by s square is equal to integral 0 to t f of t dt. Okay, look at the first problem. Find L of integral 0 to t cos t dt, that is equal to, what is the form? L of integral 0 to t f of t dt is equal to 1 by s f of s. Therefore L of integral 0 to t f of t dt, we can use t notation also. Okay, so L of integral 0 to t f of t dt is equal to 1 by s into f of s. Here, so first we have to find out f of s, that is f of s is equal to L of f of t, that is equal to, what is the function here? F of t is cos t, therefore it is equal to L of cos t. What is L of cos t? L of cos wt is s divided by s square plus w square. Here w is 1, therefore it is s divided by s square plus 1. Therefore L of integral 0 to t cos t dt is equal to 1 by s into f of s is s divided by s square plus 1. Therefore that is equal to 1 by s square plus 1. Okay. Then next question is find L inverse of, second question is L inverse of 1 by s into s square plus w square, that is it is of the form L inverse of 1 by s square plus w square divided by s. So what is the form? It is of the form L inverse of f of s by s. What is L inverse of f of s by s? L inverse of f of s by s is equal to integral 0 to t f of t dt. So here f of s is equal to, f of s is 1 by s square plus w square, that is our L of f of t. So first we have to find out f of t. So what is f of t? F of t is equal to L inverse of f of s, that is equal to L inverse of 1 by s square plus w square. We know that what is the inverse transform of 1 by s square plus w square? If it is w divided by s square plus w square, we know that it is sin wt. So we can multiply and divide by w, that is w into s square plus w square. We can take w outside since it is a constant. 1 by into L inverse of w divided by s square plus w square. So what is L inverse of w divided by s square plus w square? It is our sin wt. So f of t is equal to 1 by w sin wt. So what is L inverse of 1 by s square plus w square divided by s? It is of the form L inverse of f of s by s, that is equal to integral 0 to t f of t dt, that is equal to integral 0 to t f of t is 1 by w sin wt dt. Okay, that is equal to 1 by w into, what is integral of sine wt with respect to t? Integral of sine wt with respect to t is minus cos wt divided by derivative of wt with respect to t, it is w, therefore it is varying from 0 to t, that is minus 1 by w square into, applying the upper limit, it is cos wt minus t is equal to 0 cos 0. This is our final answer. Minus 1 by w square into cos wt minus cos 0. Cos 0 is 1. Okay. Then look at the next question. Find the inverse transform of, find L inverse of 1 by s square into s square plus w square. We can rewrite it as L inverse of 1 by s square plus w square divided by s square. Then it is of the form L inverse of f of s by s square. So what is our f of s? F of s is equal to 1 by s square plus w square. We know that L inverse of f of s by s square is equal to integral 0 to t, integral 0 to t, double integral f of t dt dt. Okay, so first we have to find out f of t. We know that f of s is equal to L of f of t is equal to 1 by s square plus w square. So that implies f of t is equal to L inverse of 1 by s square plus w square. In the above problem we know that L inverse of 1 by s square plus w square is 1 by w into sin wt. Okay, so L inverse of f of s by s square, that is equal to L inverse of 1 by s square plus w square divided by s square, that is equal to integral 0 to t, integral 0 to t f of t is 1 by w sin wt dt dt. Okay, in the general formula it is tau, we can use t also. So that is equal to integral 0 to t. In the above problem we know that if you differentiate first with respect to if you integrate first with respect to t, we get it is 1 by w into, so integral of sin wt is minus cos wt divided by w varying from 0 to t dt, that is equal to, that is equal to integral 0 to t minus 1 by w square into, minus 1 by w square into cos wt minus 1 dt. Okay, again you have to integrate this one. Integrating we get minus 1 by w square is constant, you can take it outside. Integral of cos wt is sin wt divided by w minus integral of 1 with respect to t is t varying from 0 to t, that is equal to minus 1 by w square into, applying the limits to the first term, that is 1 by w into sin wt minus sin 0, then applying the limits to the 0 is t minus 0, therefore that is equal to minus 1 by w cube into sin 0 is 0 sin wt minus plus 1 by w square into t. So this is the final answer, minus 1 by w cube into sin wt plus t by w square.